Good evening to one and all. Is the AV clear? Say. Thank you. So, let us begin our today's session on matrix of a linear transformation. Now, let me recall the definition of linear transformation one more time. That is, whenever we take two vector spaces U and V over the same field F, then we can define a function T from U of F to V of F such that the property will be anything. And if it satisfies the condition that for every vectors alpha and beta belongs to U, and for any scalars A and B belongs to F, T of A alpha plus B beta is equal to A into T of alpha plus B into T of beta. Or you have the other condition that T of alpha plus beta is equal to T of alpha plus T of beta, and T of A alpha is equal to A into T of alpha. Now, using this property of linear transformation, we can build a relation between the transformation and the basis of the vector spaces. In particular, suppose let us say B is a basis, or B1 is a basis for the vector space U, and B2 is a basis for vector space V. And T is a function, the linear transformation from U to V. Now, using the bases B1 and B2, you can represent T in the form of a matrix. In other words, the bases B1 and B2 together constitute to form a matrix for the function T. That matrix we are calling it as the matrix of a linear transformation. The advantage of this is whatever the properties are satisfied by the transformation or the function T, the same properties will be satisfied by the matrix. So, we symbolically denote it as T at B1 comma B2 is equal to some matrix. What are the matrix you will get? That matrix we take. Is it clear? What is the concept of matrix of a linear transformation? Say. Any doubts? Later I will give the procedure how to find the matrix. Are you clear with this or not? Now what is the procedure to determine the matrix of T? The first part is, for every transformation you have a condition. Say T of xyz is equal to something, and you should have two bases, one basis for the domain and other basis for the codomain. So the first part is, you find a linear combination for codomain basis. Second, apply T for domain basis. Third, for images, apply linear combination of 1. And fourth, the scalars in linear combination will be written as columns of matrix. So this is the procedure to find matrix of T. So please take a note of that. Right. Now what happens if T is a function from V to V itself? That means domain, codomain both are same. In such cases, we do the same procedure for one single basis. So the procedure is same for finding the matrix of T. If domain, codomain both are distinct, that is the procedure we actually follow. If domain, codomain both are same, in such cases also we follow the same procedure. There is no difference at all. Is it clear? Now let us take some interesting problems on this, and we will have a discuss on this also. And just give me a moment, I will try to find some good number of problems for you. Just give me a moment. Right. Now for convenience, let us define the function T from r cube to r square as x plus 3y plus 2z comma x minus y plus z. Find matrix of T So please take a note of that. Now here I got a function t and I have two bases. So if you observe that you are converting a 3D vector into 2D vector by means of this transformation. So if you observe that this is the domain basis and this is the codomain basis. So if you look at the procedure which is given earlier, the first step is find a linear combination for codomain basis. So it means that whenever I take a vector xy in R square, then I need to write that vector as a linear combination of the codomain basis. So I am going to find the scalars of a, b values in terms of x and y. So let us do that. So this is equal to a plus 2b comma 3a plus 5b. Equating the values, we have a plus 2b is equal to x, 3a plus 5b is equal to y. Now can you solve and give me the values of a and b? Can you do that? So please give it that. What is the value of a and what is the value of b in terms of x and y? So can I say that b is equal to 3x minus y? Accepted? Yes or no? And a is equal to 2y minus 5x. So if you have written the linear combination, it will come like this. So this is step 1 in which I got the linear combination. Now I have to go for step 2. So from the procedure which is described above, step 2 is nothing but for the domain basis we should apply t, right? So you calculate t of 100. So applying the values here, what is the value there? 1 comma 1, right? T of 110. You accepted all for the images? I have applied the condition t. Right. Now I have completed 2 steps. What is the third step? For the images, I have to apply the linear combination. So you feel that this is x, this is y, and apply the linear combination. So 2y minus 5x is nothing but minus 3 into 1 comma 3 plus 3x minus y 2 into 2 comma 5. Again, for this also, if you apply the combination 2y minus 5x three x minus y this is the value. And again, for this one, if you apply 2y minus 5x plus 3x minus y all of you agree with this combination? Please check that. So please remember, this is the order for calculating matrix of transformation. Step 1, finding the linear transformation. Step 1, finding the linear combination. Step 2, calculating the images. Step 3, using this combination for the images, you should find a linear combination. And step 4 is the final one. Whatever the scalars obtained there, you have to write them as columns of the matrix. So this is the first thing, in which minus 3, 2 are scalars. You are going to write like this. And from this, the scalars are nothing but, and here the scalars are nothing but so this is the matrix of T with respect to the given basis. Please take a note of that. Any doubts for anyone over this procedure? Say. Is it clear to everyone? Right. So can I erase this? We call it as the matrix of the transformation with respect to the given basis. That's why we call it as T at B1, B2, the matrix of the transformation. Right. So since you are getting, I will say, the matrix gives the geometric view of T. So what actually the transformation will do for a given vector? So you know what is the purpose of a matrix? The matrix usually does the rotation, stretching of a vector, turning a vector, etc., etc. So these things all together put in the form of a matrix. So whatever the transformation done by T, that will be showcased by means of a matrix. In other words, if I want to know, let me say, what is the value of T of 1 to 3, right? If you multiply the matrix and this vector, the result is nothing but T of 1 to 3 value. Okay? Are you getting the idea? So apart from applying the function, you simply multiply with the matrix. That was the actual thing here. So we call it as the matrix of the transformation with respect to the given basis. Now let us take the other one. Suppose basis is not specified. Suppose basis is not specified. Let me say T is a transformation from U to V. For V, I know the basis, that is, basis is given there. For U, no basis given. So in such cases, for the domain basis, we consider the standard basis. Which is nothing but the combination of ones and zeros. If I say T from R cube to R square, for this I have given a basis that 1, 3, 2, 5. For this, I didn't give any basis. In such cases, here we consider the standard basis and we do the procedure as it is. Okay, so whenever one basis is not specified, then we do the procedure by using standard basis. So that you please take a note of it. And I already mentioned that when only one basis is given, it is an operator. So T from R cube to R cube and R square to R square. In such cases, we do the same procedure for single basis only. So for that, let us take one sample problem which gives an idea for us. Okay. So the problem is, suppose T is the linear transformation taken from R square to R square, and it is defined by T of xy is equal to 2x minus 3y and x plus 4y. So I want to consider the basis here as one, 3, 2, 5. So here understand that since one basis is given and T is from R square to R square itself, so we simply write that T at B. If you are finding the matrix of T with respect to two distinct bases, in such cases we write T at B1, B2. If you are using only one basis, in such cases we write T at B. That was the difference. Okay. Are you clear with this? Right. In the previous problem also, I have considered the same basis. So I am skipping first part of the problem, that finding linear combination. So the linear combination is nothing but xy is equal to 2y minus 5x into 1 comma 3 plus 3x minus y into 2 comma 5. So this part I have extracted from the previous problem. Now I am entering into step 2. What it is? Applying the condition of T for domain basis. So I am going to calculate t of 1 comma 3. So using that value, it will be -7 and 13. Again, t of 2 comma 5. You accept it? Yes or no? Right. Now, for these images, I am applying this combination. So please tell me the respective values using this combination for this one and this one. So 2y minus 5x into 1 comma 3 and 3x minus y into 2 comma 5. Right? So whatever the scalars obtained there, we write them as columns of the matrix. So this is the required matrix of T at B. Now you can understand the difference between when different bases are given and same bases are given. Is it clear to you now? Now one observation is, while doing the previous problem and the current problem, whenever you have taken the function from r square to r square means having the same dimension, then you are getting a square matrix. If you observe the previous case, I considered the transformation from r cube to r square. The result is a matrix of order 2 by 3. From this we can say that the codomain basis gives the number of rows, the domain basis will give the number of columns. So here, if you say that T from U to V is a transformation, then if you find matrix of T, then its order is nothing but dimension V cross dimension U. So codomain basis will come as number of rows and domain basis will come as number of columns. Please understand that if there is only one basis is given, then we should do the procedure for only that basis. Usually when two bases are given, then based on the hierarchy, which one is domain basis and which one is codomain basis, we do the same procedure. That's it. That's why we should be careful that whether there is only one basis given or two bases are given, are they distinct or same, we should understand that. I have given one more thing, that if there is no basis specified, then we should always take the standard basis. I will say one simple thing. Suppose I have given a question that this is my function T of xy from r square to r square, and apart from giving a new basis, I simply asked that what is matrix of T? Here I didn't specify any basis. In such cases, we simply consider standard basis and we will do our part, because no basis is given that. Since it is a standard basis, there is no need to do the linear combination, the first step in the procedure, because whenever you take a standard basis, the image values are nothing but the linear combination scalars, because you are writing the combination of ones and zeros. There is no need to calculate the scalars separately, right? So if you consider T of 1 0, from the definition of T, its value is nothing but 2 comma 1, and T of 0 1, its value is nothing but minus 3 comma 4. And it is evident that since it is standard basis, 2 into 1 comma 0 plus 1 into 0 comma 1, minus 3 into 1 comma 0 plus 4 into 0 comma 1. So the scalars are nothing but the images values as it is, because you are using a standard basis here. So 2 1 minus 3 4. This is the matrix of T. So this thing you can apply for 2 by 2, 3 by 3, 4 by 4, and so on, n by n. Whatever the thing is there, it is true for standard basis. You can observe that the coefficient of x values will come as one column, the coefficient of y values will come as another column. Did you notice in that matrix? So whenever standard basis is given, we simply consider what are the x coefficients, you write them as column. What are y coefficients, you write them as column. What are z coefficients, you write them as column, and you will get the required matrix of T. That's all, because you are using a standard basis. So if you use any other basis, the matrix will vary. So matrix of the transformation will vary from basis to basis. That is very important. Matrix of the transformation will vary from basis to basis. Okay? Are you clear? Fine. Now, another interesting thing is the relation between the matrix and the transformation is, you know about Cayley-Hamilton theorem, that whenever you take a square matrix, it satisfies its characteristic equation. So if I say that A is a matrix and its characteristic equation is nothing but, say, lambda cube plus 3 lambda square minus 5 equal to 0. From this we can understand that A satisfies the equation A cube plus 3a square minus 5i is equal to 0 matrix. If you know that this matrix is a matrix of a transformation, then the same equation will be satisfied by T. In other words, characteristic equation of A is nothing but characteristic equation of T. So Cayley-Hamilton theorem also states that every linear operator T satisfies its characteristic equation. So we can simply say that T cube plus 3t square minus 5i is equal to 0. Here 0 stands for 0 matrix. Here 0 stands for 0 function. The result is 0. If you substitute any point in this relation, you will get 0 as output. So here I means unit matrix 1 0 0 0 1 0 0 0 1. Here I means identity operator, I of x equal to x, I of alpha equal to alpha. That is the thing, right? Another thing is, if you want to know whether given function is invertible or not, then it is very easy to say that from the matrix, if A is invertible, then T is also invertible. So how do you check that A is invertible? We simply calculate determinant of A. So if determinant of A is not equal to 0, A is non-singular matrix, hence T is also a non-singular transformation. That you can check, right? So apart from getting the invertibility of a function, if you know the matrix of the function, then automatically you can check whether the function is invertible or not by simply calculating the determinant of that matrix. Any cross questions, please? To anyone? Please tell. The question is confined to only real domain, not for complex domain. That means you are not dealing with the complex values. We always deal with the real values. Please understand, T is actually a function. You are associating a matrix for that function with the help of a basis. Now you get the concept? Actually, T is a function. Apart from applying the function, you will get the same result if you associate or if you can assign a matrix for the T with the help of basis. Fine? In other words, you are representing function in the form of a matrix. That is nothing but matrix of the transformation. In this question, T is a function. A is matrix of T with respect to the basis given in that problem. So the interconnectivity between matrix and transformation is nothing but whatever the properties satisfied by the matrix, same properties will be satisfied by the transformation. Fine. So if I say that the matrix A has no inverse, immediately I can say that the transformation T has no inverse. Just like that. If I say that the matrix A is in the triangular model, then you can say that the transformation T acts as a triangular thing in the geometric view. Fine. That's it. Any other queries? Okay. Let me take some problems which are based on the previous year questions. Please understand that the matrix of the transformation is not only applicable for the regular functions, for all type of vector spaces things. It is not confined to a specific one. So just give me a moment. I want to take one previous year question which gives a very good idea over this concept to you. Yeah, I will repeat the question, don't worry. I am still writing the question. See, this is one of the previous year questions. Here we have the set of all polynomials of degree n. I have considered it as a vector space. Let me say, if I have written P4, it means that it is a vector space containing all polynomials of degree up to 4. So I take first degree polynomials, 0 degree polynomials, second degree polynomials, third degree polynomials, and fourth degree polynomials. If I write P2, I will take second degree polynomials, first degree polynomials, and degree 0, that is constant polynomials. So I am treating the polynomials as a vector space here. So if that is the definition, the symbolic notation of P2, P3, P4, etc. Now I am defining the transformation T from the vector space P2 to P3. That means second degree polynomial space to third degree polynomial space. How I am defining? Whenever I take a polynomial f of x in the domain, t of f of x is equal to integral 0 to x f of t dt. In this way, I am defining the function, the transformation. If that is the case, then what could be the matrix of t? And with respect to these bases, I should say. So if you observe that 1x x square, it contains 3 values. This is the basis for P2, the domain, because the highest power of x is 2. In P2, the highest power of a polynomial is nothing but 2. If you observe this basis, 1x, 1 plus x square, 1 plus x cube, this is a basis for codomain, because here the highest power of x is 3, here the highest power of x is 3. Now, did you get the question concept here? What it is asked actually? Right. Now let us begin the part. So please understand how the transformation is defined. Whatever the polynomial you take, you are integrating it between the limits 0 and x. So as usual, in order to get the images for the domain values, we should apply t. So let us consider t of 1. It is nothing but integral 0 to x 1 dt. Nothing but t between the limits 0 to x. So the value is nothing but x. Now please understand that I have done 2 steps here. One, I have calculated the image using the part and I have obtained the image. Now in order to write the matrix, we need to get the scalars using the codomain basis. So here this is the codomain basis. So we should write the image using these basis values. So how it comes? It is nothing but 0 into 1 plus 1 into x plus 0 into 1 plus x square plus 0 into 1 plus x cube. Accepted? I need to write a linear combination using the codomain basis for the image. I will go for one more thing. Suppose you calculate t of x. For the second element in this, I am applying this. So nothing but integral 0 to x t dt. Now I need to apply the codomain basis for getting a linear combination here. So how can I do it? So can I write like this? Please check on the linear combination, how it is written. The image x square by 2 is written using the codomain values 1 x, 1 plus x square and 1 plus x cube. Any doubts in writing that linear combination to anyone? Are you clear with it? Right? So if you get the third one, t of x square, it is nothing but integral 0 to x t square dt. Now the image x cube by 3 should be written as a linear combination of the codomain values. How it can be taken? Just like the previous one. So if you observe, in each combination what are the scalars, you write them as a matrix. In the first one, the scalars are nothing but 0, 1, 0, 0. So write them as columns of a matrix. In the second one, the scalars are nothing but minus 1 by 2, 0, 1 by 2, 0. The third one, the scalars are minus 1 by 3, 0, 0, 1 by 3. So this is the matrix of T with respect to the transformation and with respect to the basis. So earlier we calculated the matrix of, because you need to get x square by 2, right? So I am using, I have only these things are available. 1 x, 1 plus x square, 1 plus x cube. So in order to get x square by 2, I can write 1 by 2 here. So I will get 1 by 2 plus x square by 2. But I require only x square by 2. 1 by 2 should not be there. That's why I have used 1 also. So minus 1 by 2 into 1 and 1 by 2 into 1 plus x square. In that way I have written. Clear? So the output image should be written as a linear combination of the codomain basis values. Whatever the basis which is given, I should write like that. So any doubts for anyone over this method? Or is that clear? And one interesting thing is, if I have posed one more question, that what could be the null space of T here? What could be the null space of T here? The thing is, let us write the definition of null space of T here. or here the thing is this is the definition of n of t. We will consider the polynomials in the domain such that whose image is the 0 in P3. Here 0 means the 0 polynomial in P3. So if you consider that, since the function is defined as now here, for what polynomial if I integrate, the result is nothing but 0. It is just the 0 polynomial, right? So if you take any non-zero polynomial in the domain, if you integrate that, will you get 0? If you take any non-zero value in set of all polynomials P2, if you integrate that, will you get 0 as a result? Say yes or no? It means that the null space contains only 0 polynomial, because integral 0 to x 0 dt is equal to 0, and integral 0 to x f of t dt is equal to 0 only when f is 0. If you take f as non-zero, this value will be non-zero. Accepted? If f is a non-zero polynomial, if you integrate that, you will get the result as non-zero. Accepted? So in order to get 0 only, the polynomial you should take in the domain as only 0 polynomial. So null space of t is nothing but 0 polynomial only. Fine. So apart from doing this, you can do one more thing. As we have studied the connection between the transformation and matrix. So this is the matrix of T. Can you calculate the determinant of this matrix? Is it possible to calculate? No, because it is not a square matrix. So from this, you cannot say that whether the function is invertible or not. So since it is not a square matrix, we can say that the function is not invertible. The transformation is not invertible, that you can say. And for calculation of null space, we go with the definition. Simply write the definition of null space and check for what values in the domain you are getting 0 as output. So if you are clear with this problem, I just want to take one more interesting problem, then let us wind up our discussion. Just give me a moment. I'm trying to take one of the previous year questions. It is given in 2016 that So it was given in 2016 that he has taken two vector spaces M2 of R and P2 of X. Please understand that M2 of R means all 2 by 2 square matrices where the entries in the matrix are nothing but real numbers. P2 of X means all polynomials of degree up to 2. That means you can take constant polynomials, first degree polynomials and second degree polynomials. So from this vector space to this vector space, I am converting a matrix in the form of a polynomial as T of ABCD. Whenever I take a 2 by 2 matrix, it was written like this. Now the question is, what could be the matrix of T with respect to the standard basis? Is the question tag clear? Say. Right. Now, first of all, let us look into the case that what are the standard bases for the vector spaces. For this, the standard base is nothing but combination of ones and zeros. Whatever the order you read, this is the standard basis for the domain. And for codomain, the standard basis is this one, 1x square. Now let us do the usual procedure. So T of 1 0 0 0. Now you give me the image for this one. So A plus B plus C, nothing but 1, plus A minus D, 1, plus B plus C, 0, into x square. Is it clear from that definition? Say. Fine. Let us take the other one. So A plus B plus C 1 plus A minus D 0 plus B plus C 1 into x square. And for the other one, and for the next one, any doubts in applying the transformation here? Say. Right. So if you observe that there is no need to write the linear combination separately again. So from this, if you write the scalars as columns of matrix, this was the matrix of the transformation. Accepted? That's it. Any other questions to anyone? Yeah, that's very simple. If you want to calculate the null space, say Accepted? This is the definition of null space. Agreed? Right. Now, if you apply the definition, please understand here the domain is a matrix, codomain is a polynomial thing. So while writing the null space, we should take care that it is the zero polynomial. The null space is defined like that. So from this you can say so if you equate the corresponding coefficients, you can say a plus b plus c equal to 0, you can say b plus c equal to 0, and you can say a minus d equal to 0. From this, all the four values will become 0. Do you accept for it, or can we do it better? Always zero matrix will give the trivial value. Apart from this, can you find any non-zero value here? There is the interesting thing here. So by solving these equations, can you get any better relation here for the values of A, B, C, D? Say. Fine. So all the values of A, B, C, D will be 0. Accepted? Then that could be the null space. Any other questions? Let us go for the other problems too. Just give me a moment, I will take one other problem. I am checking for the previous year questions. So if you take B is equal to minus C, from this A is equal to D also, right? So that's why you can take the part as is this acceptable to say that you are getting zero thing? So if you say that A is equal to D, since A and D, okay, now I got your point. Or this is the form of matrix you will get. Agreed? That's it. That's why I asked, apart from A, B, C, D equal to 0, can you find any value so that you are having null space containing other matrices? So whenever you take a matrix of this form in the domain, you will get the result as 0, 0, 0. That's why the null space is nothing but all matrices of this type that we take into consideration. Fine. Now I just want to introduce one small concept. Which is also given in the previous year papers. Yeah. This is the problem given there. I think it was given again 2016. I hope so. So you are defining the transformation from set of all second degree polynomials to set of all third degree polynomials. That means you are taking here constant polynomials first degree and second degree. Here you are taking constant first degree, second degree and third degree polynomials. And how the function is defined? Whenever you take a polynomial f of x, t of f of x is equal to f of x plus 5 into integral 0 to x f of t dt. Now, if these are the respective bases for domain and codomain, what could be the matrix of T? So let us do it together. First of all, consider T of 1. For the domain basis, apply T. So from this it is nothing but 1 plus 5 into integral 0 to x 1 dt. Accepted all? Please check that. This is the way of applying the function. And if you write the scalars, then you get the matrix as 1, 5, 0, 0. And here you have 1, 6, 5 by 2, 0. And there you have 1. This was x. So this was the matrix of T. Accepted? That's it. So do you have any other queries in the calculation of how to find a matrix of T and how to get its null space? Was the discussion considered? Anyone? Then if you are clear, we have one more topic left in this chapter. Then we conclude our linear algebra part on Saturday. And from next week onwards, we discuss the other cases. I want to take some of the previous year question parts as a discussion on Saturday with regard to linear algebra. So do you have any other queries? So here n of t is not at all asked. If you are interested, let us calculate the n of t. So just do that. Whatever the polynomial you take in the domain, so n of t is nothing but result is 0 polynomial. So you are making that f of x plus 5 into integral 0 to x f of t dt is nothing but 0 polynomial. Now how to deduce this without knowing f of t? Isn't it? That's why that part is left here. The question was not at all focused on calculating the null space of t. Yeah, however, if you are interested, from this matrix, you apply row operations on this and verify whether it is in the echelon form or not. If it is echelon form, the null space will be satisfied by the rows of this matrix. You are going to find a similar kind of polynomial, the basis. You know, for a homogeneous system, how to calculate the solutions when a matrix is given to you. We use that technique here. You need to apply the echelon form concept here. That's it. So concept of n of t is not focused, only finding matrix of t is focused in this problem. And just tell me one thing, that did you get any disturbance in the middle of the class? Suddenly it appeared that the class is logged out. I don't know actually what happened. So I will report the same issue to the admin. You can check for that. What happened actually. And tell me one thing. Someone of you are watching the recorded videos after the completion of class? Yes or no? For clarifying your doubts, etc. If so, did you get any disturbance in getting those things? Or is that clear? All right. Anyway, let us wind up our session here. That's all for today, and we will meet on Saturday. Thanks to all.